Now, one of the applications of trigonometric ratio is what we call angle of elevation and depression. So, what is the meaning? What do you mean by angle of elevation? Angle of elevation. It is the angle at which one is looking straight, and at the same time the person is looking at an object in the air. So the angle between them is what we call angle of elevation. That angle of depression is is the angle at which one is looking straight and one is now looking at another object in the, on the floor or on the ground. So in a nutshell, angle of elevation is when one is standing on the ground, you are now looking at a bed, or you are looking at an aeroplane. You're looking at an aeroplane. Okay. While angle of depression is when one is standing on a tower or on a tree. So that person is looking straight. At the same time, the person will be looking at maybe another object like hen or rat. Okay. 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 So let's look at an example on how to solve angle of elevation and depression. Let's look at this example. It says two cars A and B are on the same side of a tower T. If the angles of elevation of the top of the tower as observed by A and B are 35 degrees and 50 degrees respectively, and line AB is 5 meters. Find the height of the tower. Now, whenever we see a question like this under angle of elevation and depression, the first thing is to draw the diagram. The diagram is what will now lead us to how to solve the problem. Now, they say two cars A and B are on the same side of a tower. Anything called tower, mast, pole, they are always straight. So I will draw a straight line like this. So after that, I was told that the two of them, the two cars A and B, they are on the same side. So that means the two of them are on the ground. That's the meaning. So I'll put the ground level, I'll put it there. So now it says if the angle of the elevation of the top of the tower, this is the top of the tower. They say we should put T. So we use T to represent that. This is the top, T to represent that. So the angle of the top of the tower as observed by A. They mention A first, so A is 35 while B is 50. So I come here. Remember, angle of elevation is when you are looking up, you are looking at an object up. So from A, I'll consider this place as my A. So A will now be looking up to the tower. A will look up to the tower. So the angle is 35 degrees. Likewise, in the question, A and B, line A and B, they say the two of them are what? Close. They are on the same side. But that B, that B also has angle of elevation, which is what? 50. So that means the angle at which B is looking at the top of the tower is 50 degrees. But the distance between A and B is 5. So this is AB. I'll put 5 here. So we can represent this place with letter F. Letter F. Now, the height of the tower, let's represent that one with H, while the distance from F, so B, let's represent it with X. With X. Now, after drawing the diagram, the next thing to consider is, if you look at the diagram very well, we're having two triangles here. The first triangle is the smaller triangle, which is TFB or TBF. So that is, we say, considering triangle TBF and the bigger triangle, which is from here to A, then to F, that's TAF, and triangle TAF. Okay, we can bring out the diagram, two diagrams. For this one, the diagram is like this. We have T here, B here, then F here. Then we have angle 50 degrees. So this is X, while this is height H, according to this diagram. Also, considering the bigger triangle TAF, TAF, you can draw that one here as well, the bigger one. Draw it here. This is T. Now, angle A is 35 degrees. This is height H from diagram. But when you look at from A to F, look at the diagram. The diagram is like this. So from A to F, it means the addition of X and 5. So which means FB, line FB plus what? Plus line AB. So that is X. This place is X plus 5. Fine. After that, we now check which of the SOHCAHTOA will work. Which of them will work here and which one will work here as well. Now, when you look at it, we said anywhere the angle is facing, that's what we call opposites. There's an information here. We also have information here as well. So this is the hypotenuse, which is not necessary. We don't need it because there's no information here. So we have information at the adjacent. So likewise, this is the angle where the angle is facing. We have opposites here, and this is the adjacent as well. No information on the hypotenuse. So considering SOHCAHTOA, considering our SOHCAHTOA, so which one has O and A? In fact, it's TOA. TOA has O and A. So which means for this particular diagram, we are using TOA. For this particular diagram, we are using TOA. I'll say A triangle TBF. For triangle TBF, tan 50, that's TOA, equals what? Opposite over hypotenuse. So which is, the opposite is what? The opposite is H over opposite over adjacent. Opposite over adjacent. So the adjacent is X. Is X. So if I make H the subject of the formula, because the question says we should find the height. The question we should find the height H. So I'm making my height H to be the subject of the formula. So I'll cross multiply. X will cross to multiply here. So we'll be having H equals to X tan 50. So likewise, in triangle TAF, TAF, triangle TAF. Okay, now we are also using TOA, which is tan 35 degrees equals to opposites over adjacent. So the opposite here is H over the adjacent is what? X plus 5. X plus 5. So if I make H the subject of the formula, X plus 5 will cross, it will cross multiply with this side. So which means my H here is what? Is X plus 5 times 35. So I'll call this one equation 1 and call this equation 2. Now, we are going to equate equation 1 and equation 2. So I'll write equating equation 1 and equation 1. and equation 2. So this is h. So that means this side is equal to this side. So left hand side equal to left hand side will cancel. The right hand side will also be equal to what? Right hand side. So which means I will write x times 50 equals x plus 5 times 35. So from here, I'll be looking for uh, how to use tan 35 to open the bracket so that I can make x the subject of the formula. Now let us open the bracket so that we can make x the subject of the formula. So open this bracket, we have x tan 50 equals tan 35 times x. I will get x tan 35. Then plus tan 35 times 5. Remember, the number stays at the front. I'll write 5 times 35. So I'll collect like times for x. For x. You are collecting like times for x. So if I'm to collect like times for x is here, x is here. So which means I'm bringing x times 35 to this place. So we are going to have x times 50 minus x times 35 equals, I'll be left with 5 times 35. So I can easily factorize. X out. X is here, x is here. So I'll bring x outside. Open bracket. So if the x here is gone, I'll be left with what? Tan 50 minus the x here is also outside. I'll be left with what? Tan 35. So equals what? 5 times 35. Then from here, we divide both sides by the coefficient of x. So we divide both sides by the coefficient of x. So which means tan 50 minus tan 35 will divide here and also divide here too. So when tan 50 minus tan 35 divides here, it will cancel. I'll be left with x. This side is cancelled. Equals to, I'll write 5 times 35, then divided by the coefficient of x, which is tan 50 minus tan 35. And when we find 5 times 35, we are going to get 3.5010. Likewise, tan 50 minus tan 35. From our calculator, we are going to get 0.4915. Now, using calculator to divide the two of them, we get our x, which is 7.122 meters. Now, the next thing is that we want to find our height h. So we can easily do this one by substituting into either equation 1 or equation 2. So, but equation 1 is simpler. To substitute into equation 1 is more simpler. So, which is h equals to x tan 50. Then our x already is 7.122 times tan 50 degrees. So 7.122 multiplied by tan 50 will give us 8.487 meters. Then we can now round it up to one place of decimal. One place, this decimal, so after decimal, the first number there is 4. So I'll look back, which is 5 and above. So I'll add 1 to 4. So I'll be getting 8.5 meters. Therefore, the height of the tower is 8.5 meters.